Dr. Doug Reinemann and Dr. Liliana Fadul. Doug Reinemann is a professor and the Dean for Outreach and Extension at the University of Wisconsin-Madison, and a complete privilege to have him on board with us here today, given his expertise in milk harvesting and milk quality. Liliana Fadul is a postdoctoral research scientist and a dairy data scientist working on the Dairy Brain project. So it's a privilege for us to have both of you here today. I'll share presenter rights with Doug first.
I trust you can see the slides and hear me. I'm going to present some work that we did and presented at a recent precision milking conference. So it was in Cork, Ireland. And you can see the group that worked with me on this project. And the question we approached with this study was, can box-style AMS systems be economically competitive? And so what we mean by competitive is the US trend right now for new dairy construction is rotary milking parlors built for units of 3,000 to 4,000 cows, very high labor productivity, but you heard about the concerns about the availability of labor, so farms are looking at robotic milking. Most of the installations in the US have been box systems, and most for smaller farms like the one pictured here. There's recent interest, as you heard, with larger farms, and some new technologies, automated rotary robots, and with moving arms and stationary arms. So my question again was, can the box-style AMS be economically competitive with these other types of systems? And one of the motivating factors for that question is the box systems are better suited for smaller farms, and there's a lot of interest in Wisconsin in keeping small farms in the dairy business. And I think they have advantages in terms of cow environment. I think they have advantages in terms of milker labor environment. So I'm pulling for the box style systems. And so my question is, can they compete? So just to give an overview of the cost of milk production, the slice that we're looking at in this particular study is the green slice, the capital recovery cost. So the capital cost of the robot is a significant challenge to make economically viable. But of course, the feed cost on any dairy operation represents the largest percentage of the cost of producing milk. And we'll see a few words about those and just a few words about the labor slices as well. So we did a model based on data from a large commercial AMS farm in the US. And I was particularly interested, or the question for this model was, what were the best predictors of milk harvested per AMS box per day? And because that is the primary economic factor that accounts for that capital recovery cost of the robot. So our model results, when you looked at it from the standpoint of a box over the course of a day, the best predictor was the amount of time that the box was actually used for the milking process. And that explained 85% of the variation in milk per box per day. And then what I'm calling box AMF, or the kilograms of milk harvested per minute of box residence time of a cow, explained about another 14%. And all of the other factors predicted less than 1% of the variation in milk per box per day. And then looking more at that box AMF number, the factors that influenced that were the udder level average milk flow rate, or kilograms per minute of milking time. And then the udder yield, so higher producing cows had a higher average milk flow rate. And the box prep time had some influence on it as well. So those are the really the predominant factors. And so we were looking at, where are the opportunities to improve the economic productivity. And so we did some a theoretical model on what are the limits to this efficiency. So the first thing we looked at was the box milking time per day, or box utilization. The current average, well, this is a bit dated data, but two big surveys that were done in the US and Canada showed that the average box utilization was about 17 hours per day. And I predicted that the theoretical maximum is something closer to 22 hours per day. So you can see there's a lot of room for improvement there in terms of just the utilization of the box. And of course, to capture that advantage, you need enough cows with enough milk to get the advantage of increasing the box utilization. So the second largest factor having to do with the box AMF, just sort of starting with the prep time. Again, sort of the current average is 2.8 minutes or almost 3 minutes. And for this one, I thought we could go as low as about 2 minutes. There's a point at which if you decrease the preparation time, you don't actually increase the milking time, because there's some time involved with stimulation and prep lag times. And so I set that at 2 minutes for a theoretical minimum, and that produced about a 9% increase in the box AMF. And then the other thing we are looking at, and you'll hear a little bit later about this from my student Pablo, who's in Ireland right now, we could milk faster, and sort of the logic here is it doesn't really help us to milk the fastest milking quarters faster, but it does help us to milk the slowest milking quarter faster. So that was the premise of this model, that we could milk the total udder in the time it takes us now to milk 3/4. So basically remove the fourth quarter, or milk the fourth quarter as fast as the next slowest quarter, or the third quarter. That produced a 28% increase in the udder AMF. And the other thing which was really the interesting part of this study is that when you look at how cows are being milked, this on the lower right-hand corner is just a distribution of the milk harvested per milking, and you can see it's a reasonably normal distribution. And there's a lot of cows that are being milked that have relatively little milk in their udders. And so the strategy here is we want to increase the milk yield permission so that we're not spending robot time or box time milking cows with empty udders. So the strategy was that, in our model scenario, was that for early lactation cows, less than 50 days of milk, we would set a time-based permission of somewhere between 4 and 6 hours permission. And then after 50 days of milk, the permissions would be increased to, we had two model scenarios, 12 or 15 kilograms per milking. On the lower left-hand side, you see the milk production rate based on days in milk. And so that those first on this particular farm, about the first 40 days, you have this rapid increase in milk production, and that's the period in which you really want to have, at least 3 or 4 milkings per day on a cow. There's relatively little advantage of going from 4 to 5 milkings a day, but in that early lactation, there's a significant advantage. And then after you hit that peak milk, then switching to a permission-based strategy and letting the udders fill up before we milk the cow. So these are the results of the model, sort of the theoretical maximum, and there's several things going on here. So been a lot of talk about production per cow, milk production rate per cow. So I've modeled 3 scenarios from 30 to 50 kilograms per day. And 30 is sort of around the average for US farms right now. Some of our best farms are, at 40 kilograms per day, and our very high producing herds are approaching that 50 kilograms per day. So the milk production is really an economic calculation of income over feed cost. So there are some situations in which, given the feed resources you have, it might make sense to have lower production per cow. And in other cases, depending on the cost of your feed and the availability of your feed, it might make sense to have a higher production per cow. So the theoretical maximums you can see for the 15 kilogram milking permission is 3,800 kilograms per box per day. And then you can see how that relates to the number of cows per box and the milking frequency per cow. And the first thing that you'll see is that the number of cows per box is considerably higher than is current practice. So at least the 2016-2017 studies showed in North America, the average was between 51 and 56 cows per AMS. And the question is, can we actually get that many cows? There we go. Can we actually get that many cows through an AMS? And that's a question of, can we come up with barn designs that will enable that kind of cow flow and not suffer in terms of dry matter intake or cow comfort? So we've got some farms that we're working with in Wisconsin. Some of these are enrolled in the Dairy Brain Project. And so our Wisconsin user group, we have farms ranging from 2,000 kilograms per box per day up to about 3,200 kilograms per box per day. And on that, the range of box usage goes from about 60% or 14 hours a day up to the very highest kilogram per box per day has achieved a box utilization of 90% or 22 hours per day. So you can see my theoretical maximums there. We actually have one farm in Wisconsin that's approaching that, and we're working with that farm to see if they can get a little bit closer to that number. So again, this analysis primarily deals with the capital recovery cost. We're also really interested in the economics of precision feeding. Right now, we see that with the farms we're working with, you can get more production by feeding more concentrate in the robot, but the economics of that are not favorable. And then the other big component is the question of labor costs and, how much labor would it take to operate one of these kind of high producing farms. So the question, one of the question I'm particularly interested in is what will the future look like in terms of automatic milking? Will it be small farms with AMS boxes, large farms with AMS boxes, or large farms with AMS rotaries? I'm convinced that it will be automatic milking of some form. And again, for reasons I stated, I really am hopeful that the box systems can be economically competitive, stay in the marketplace for the benefits they provide to farm families and for the dairy cows. So with that, I'll turn it over to Liliana.
Thank you very much, Doug. I've got like a million questions to ask you, and we've got a student next to me here that is also screaming for questions, but we'll turn over to Liliana now and tackle some of those questions afterwards, but thank you very much for that.
I'm gonna do this very quick since I guess we are short on time. I'm gonna briefly explain you what is the Dairy Brain project. I want to quickly mention that the Dairy Brain team is a multidisciplinary team. They are people from the Dairy Science Department and the Computer Science. These projects started 2 years ago with a sea grant of the university, and this year we got a grant from the United States Department of Agriculture, so we're going to continue working on this for the next 3 years. So the situation right now in the dairy farms is that we have different type of data and different type of softwares coming from. So we have sensor data, automatic milking or parlor data, feeding software from the Dairy Herd Improvement Association data, genetics, processing, weather, prices. And these data are normally very low integrated, or the integration is almost inexistent. Therefore, taking it and making use about it, like to make like continuous decision and day-to-day decision, is very complicated. Also, because this data come from different softwares, all the integration is also very challenging. In a short survey that was done last year here in the Wisconsin about 3,000 dairy farms, they found that at least they wanted to know what was the digital technology and the internet use among farmers, and they found that 10% of the farmers at least use one of the technologies, and 2% of the farmers use automatic milking systems. This is a growing tendency. Therefore, with all this technology, also like more data is coming, so we need to do something with it. So the big picture of the dairy brain is to collect the data on farm, bring the data to a central location, transfer all the data here to a central location that will be here at the university, transform the data, standardize the data among the different softwares, and then apply service analytics to give added value to this data and return it to the farm, and help the farmer to make better decisions according to the actual data and the continuous data that is happening on the farm. So the project have like 4 different objectives. The first one is to create the coordinated innovation network that is going to be the baseline of the project. The second is to create the agricultural data hub to gather all the and process all the data. The third one is to develop the analytical models that will be our dairy brain. And the last one will be to design and execute an extension program. So basically, the Coordinated Innovation Network is defined by the USDA as a community that addresses bottlenecks in critical areas by bringing together experts from different disciplines and domains to identify, innovate, and synergistic solutions. So we have, to the moment, we have 62 members. And if anyone is interested, is open to address and to engage with us in the discussion and engage in the process, you're welcome to join. The information is in the web page. And Nico have my contact also. If you want to write me, I can give you more details. And among the objective of the CIN is to raise awareness and create guidelines and facilitate the process of exploring critical issues as data security, data ownership, among others. Those are going to be the discussions that we are going to write in some design documents that will be kind of the guideline. So as I mentioned, there are like data ownership, data security, best practices for data collection and communication, using IPAs or application of programming interface, and what are like the different strategies that we can use to access the different IPAs through the dairy industry. The agricultural data home, as I mentioned, it will be like to collect, harmonize, and store all the data, and then this will be able, according to what the CIN and the farmers decide, to distribute this data on the safest way possible via APA or human. And the last part, and the most interesting, is the dairy brain, which is the one that is going to be the decision support tools designs. So the idea is to give the value added to all these data integrated by applied advanced analytics. So we're going to have different decision support tools. So according to what we have discussed with the farmers here in Wisconsin and to our CIN, we have like some short-term, mid-term, and long-term. We have a short-term is going to be the feed efficiency and milk income over feed cost. We have been working lately, brand new, in some robotic farms, only really in the milk offer the supplement cost, to see what is going to be like because to exploring a little bit the economic part of the feeding in these systems. And I just want to mention and to show you that it's the calculator, for example, for feed efficiency is pretty basic, but however, you are going to need at least 2 or 3 different data sources according to what is going on in your farm. And the same thing is going to happen with the income over feed cost. If your milking parlor have milk components, well, you're not going to need the herd level processor, but you're going to need the economics and you're going to need the feed information. And as we advance in the different decision support tools, they are like getting more complex, if you want to call it like that. So we are going to need more data sources to do the different ones. And this one is the last one that is long term. So you need almost 5 different data sources to get these decision support tools. So the overview of it is kind of the coordinated innovation network is going to deal with it, with the design documents. We're going to have the agricultural data hub that is going to condense all the information, all the data that is coming from the farms, and the dairy brain that is going to process all the information that is going to go back to the farms. The last part is going to be the extension. That's going to be, we want to show all the benefits of the data integration. So we're going to work with agents, farmers, industry, and advisors. And we're going to do different webinars, workshops, and to show the benefits of it. So I think with that, like on time. So thank you very much.
Thank you very much, Liliana. Fantastic insight into a topic that I think is only going to grow moving forward regarding data sharing and benchmarking and analytics. So thank you for that. So we've got a couple of minutes for questions. I'll start with you, Liliana, given that you're here at this time. Do farmers have any constraints or any issues around data sharing? And is there any cost in participating in this project?
No, surprisingly, they don't have. I can say that they have a really good relationship with the university. So I think that really facilitates like the confidence with us. And no, there is absolutely no cost to participate on the project.
Thank you for that. Doug, a couple of questions for you. The first one is, how did you calculate the potential of the robots?
Well, the optimization function was to maximize milk per robot per day. And so we just we used something called the GLM select procedure. So we just threw a lot of predictive variables at the model. And, you know, again, the question was, what were the primary factors in predicting milk per box per day? And so that was the structure of the model, the modeling method, and the results reflect, you know, maximizing that milk per box per day.
Perfect. The second question is, what are your thoughts regarding the risk of running at capacity or pushing the boundaries in liters of milk per robot?
Well, that's a great question, and that's exactly what we're working with our user group farms, and we're approaching that very carefully and thoughtfully. So, you know, we're working with 6 farms and with a variety of barn designs, and so we're taking small steps. And I will just say that so far we're able to make substantial improvements, at least on some of those farms. I think one of the challenges I see is that in order to achieve the kind of efficiency that's theoretically possible, we don't have enough stalls in a lot of barns. So that's a limitation we're running up against. I would say that people should consider building the barns somewhat bigger so that the efficiency of the robot doesn't get capped at a certain level because of the barn size.
Excellent. And I think I do agree with you. We see the same over here from research that we did looking at commercial farms. The average commercial farm could improve milk per robot or robot time, depending how you look at the efficiency, in up to 60%. And that's a great opportunity for farmers out there. The last one is, do you see that there's being more improvement to improve yield per box around the efficiency of the robot itself, the genetics of the cows, or the management at a farm level?
I have to say that all three of those are important factors. But I would, and the results of the model really suggest that the easy near-term gains are to put more cows per robot, regardless of what production you're at. The easiest way to increase the productivity of the robot is to add more cows. And the permission settings that we've modeled, the reason that people don't add more cows is they essentially run out of box time. And so the permission settings they open up some box time so that you can add more cows.
Yeah, it's finding the right time to milk every single cow. I think that's a great point. Excellent. Doug and Liliana, thank you so much for your time and your insights. Always half an hour seems too short to hear all the knowledge that everybody in this showcase has, but I do appreciate your time and your willingness to share those insights with us. Congratulations for the great work you're doing, and we'll keep in touch.
Thank you.
Thank you.
Excellent. Thank you, Liliana. Thank you, Doug.